It's often said that we humans share 50% of our DNA with bananas, 80% with dogs, and 99% with chimpanzees. Taken literally, those numbers make it sound like we could pluck one cell from a chimp and one from a human, pull out the tangled bundles of DNA known as chromosomes, unroll each one like a scroll, and read off two nearly identical strings of letters. But in reality, the human and chimp scrolls don't sync up so easily. In the 6 to 8 million years since we split from our last common ancestor, chance mutations and natural selection have changed each of our genomes in radical and unique ways. Two human scrolls fused, leaving us with 23 pairs of chromosomes to chimp's 24. Other large mutations revised huge sections of text, duplicating a chunk of human DNA here, erasing a chunk of chimp DNA there, while throughout the scrolls, tiny mutations swapped one letter for another. When researchers sat down to compare the chimp and human genomes, those single-letter differences were easy to tally, but the big mismatch sections weren't. For example, if a genetic paragraph, thousands of letters long, appears twice in a human scroll, but only once in its chimp counterpart, should that second human copy count as thousands of changes, or just one? And what about identical paragraphs that appear in both genomes, but in different places, or in reverse order, or broken up into pieces? Rather than monkey around with these difficult questions, the researchers simply excluded all the large mismatch sections, a whopping 1.3 billion letters in all, and performed a letter-by-letter comparison on the remaining 2.4 billion, which turned out to be 98.77% identical. So, yes, we share 99% of our DNA with chimps if we ignore 18% of their genome and 25% of ours. And there's another problem. Just as a small tweak in a sentence can alter its meaning entirely, or not at all, a few mutations in DNA sometimes produce big changes in a creature's looks or behavior, whereas other times, lots of mutations make very little difference. So just counting up the number of genetic changes doesn't really tell us that much about how similar or different two creatures are. But that doesn't mean we can't learn anything by comparing their genomes. DNA contains a record of the evolutionary relationships between all organisms. It's a garbled record, but by reading closely, we've been able to glean enough information to refine the evolutionary trees we started drawing long before genome sequencing was around. We may not actually be 99% chimp, but we are 100% great ape, and at least a little bananas. Hi, this is Emily. This episode was brought to you in part by Squarespace, the company that will allow you, even if you have no coding or web design experience whatsoever, to make a website in 2015 that looks and acts like a website from 2015, which is to say, beautiful and functional in your browser and on your smartphone. Go to squarespace.com/MinuteEarth to try Squarespace out for free, no credit card required, and get 10% off your first purchase. Thanks, Squarespace!